Good morning! You have reached the final new lesson of the year. It is irrational numbers. Isn't that kind of cool? It's your last lesson. Uh, yeah, I hope you don't fall asleep because your teacher was so boring. Oh well, we'll stay strong. It is almost over. Okay, so that was a little fun for you guys. So today what we're going to do is we're just going to, first thing we're going to do is we're going to compare some irrational numbers. So if you remember the other day, we had estimated what their value was. And basically what we did is we took, if it's a square root, we said, okay, what are the perfect squares, one bigger than it, one smaller than it, that we know it's going to fit in between there. And we're going to do the same thing with cubes. So radical 35, well, radical 36 and radical 25 are perfect squares. So radical 25 is 5, radical 36 is 6. So radical 35 is just a little bit smaller than 6. Okay, so it's like 5.9-ish, but slightly smaller than 6. Now if we go to the cube root, now we need to remember our perfect cubes. So our perfect cubes are 1, 8, 27, 64, 125, 216. Those are the main ones we need to know for right now. So radical 80 falls in between, cube root of 80 falls in between the cube root of 64, which is 4, and the cube root of 125, which is 5. So radical 35 is between 5 and 6. Okay, cube root of 80 is between 4 and 5, so therefore radical 35 has to be greater than cube root of 80. Let's look at the next one. Okay, cube root of 65 and square root of 26. So we just remember from the last slide that the cube root of 65 is slightly bigger than the cube root of 64, which is 4. So this is just about 4, slightly more than 4. Well, the square root of 26 is a little bit bigger than the square root of 25, which would be 5. So the cube root of 65 must be less than the square root of 26 because a little bit more than 4 has to be less than a little bit more than 5. So now let's look at this one. It's a little bit different because we have negatives in there. So negative 2. So again, our perfect squares are 1 and 4. So square root of negative 1 and the square root of negative 4 is going to be negative 1 and negative 2. So the square root of negative 2 is going to be between negative 1 and negative 2. Now let's look at the negative cube root of 10. So if you remember, the cube root of 8 would be 2, so that would be negative 2. And then the next number would be the cube root of 27, which would be negative 3. So the cube root of negative 10, the negative cube root of 10 is between negative 2 and negative 3. This negative square root of 2 is between 1 and 2, so the negative square root of 2 is greater than the negative cube root of 10, because something between negative 1 and negative 2 is greater than something between negative 2 and negative 3. Now this should look a little similar to something that we did last week, and it is related. It's just that now, instead of us having a integer as our distance, we're now going to have a square root. And we're just going to have to figure out about what is the distance, and we're going to round it to the nearest tenth. So again, we're still going to use our distance formula, or we're just going to use our Pythagorean theorem like we did the other day. And we have a distance here of 2, so that's 2 squared. And then we have a distance here of 7 squared, and that's going to equal our hypotenuse, which was just c squared. So 4 plus 49 equals c squared, so that equals 53 is c squared. Take the square root of both sides. C, or the hypotenuse, is the square root of 53. Now that's slightly bigger than the square root of 49, which would be 7. So now let's make our lives easy. Let's just use a calculator to come up with the estimate. I know we went over it the other day, so let's just make lives easy. So the square root of 53 is about 7.28. So round to the nearest tenth. C is about, we do those little squiggly lines for the show an approximation, 7.3. 3. What happens if we just have 2 points? Well, again, it's the same thing, right? It was x1, y1, x2, y2. So it's going to be that's a 2, y2 minus y1 squared. So that's -2 minus -1 squared, which would then be, add those up, that'll be -1 squared, or 1. Now we do x2 minus x1, -2 minus -3. That whole thing is going to be squared, so you add those up. It becomes 1 squared, or 1, that equals 2. I'm sorry, that equals c squared. So 2 equals c squared. Take the square root of both sides. C is the square root of 2, which is about 1.4. And just to prove it to you, square root of 2 is 1.4142, so about 1.4. Let's come to the last question. The equation d squared equals 137h represents a relationship between the distance in nautical miles d. You can see with a periscope and the height h in feet of the periscope above the water. About how far can you see the periscope when the periscope is 3 feet above the water? Okay, so 3 feet deals with h. So d squared is 1.37 times 3. So d squared equals, that equals 4.11. Take the square root of both sides. D is about, well, the square root of 4 is going to be 2. Oops, I don't know. Oh, that's got to be this 4.11. 2.02, so we'll just call it about 2 nm nautical miles. All right, guys, so reach out if you have any questions. Bye.